Right. So in this video, we said we are going to talk about tokenization. So now that we did the embeddings, we want to talk about how we tokenize this text. We need to split this input text into individual tokens. And I've been emphasizing that it can be a word is a token or a subword is a token. These tokens are either those two individual words or subwords or special characters, for example, punctuation marks. What we are going to use, as you can see on the screen now, we've jumped into a bit of Python coding. I'm using Google Colab because it is much easier um, for me to get access to a GPU. These workloads require expensive GPUs. On Google Colab, I have a pro account. I have a pro account, and it gives me access to, if I want to just, let's say, I ran these codes prior, so yeah, I have access to these GPUs, but I ran the codes prior, so I'll just be showing you what the results are. If you get the codes, when you get the codes, you can upload them on your Google Colab and run them, or any platform that gives you access to GPUs. What we're going to use in this course, in this part here, is this short story by Edith Wharton. It's called The Verdict. It is in the public domain, so it is okay for us to use it. I'm not going to go into the Python codes, but feel free to read line by line. So in this course, the course is not introduction to Python. So I'll just talk about the high level details of the codes, but not really explain line by line. So here we're loading our text. We're loading our text, which is the verdict. And after that, we are going to just, yeah, we are printing how many characters there are. You can see that there are 20,479 characters. And just the first characters, the first 100 characters, these are the first 100 characters. Our goal is to tokenize this text for it to be ready for a large language model. What I can show you how tokenization works. I think let me before we really get into deep into Python codes, let me set this up so I can explain in smooth draw, or I can write it down to explain what exactly tokenization is. So let me switch this off so we go back to our drawing board or whiteboard here. So what exactly is tokenization? So imagine we have input text. Where is I'm trying to look for my pen that I used to write on my board. Okay, I found it. So imagine we have input text here. So imagine our input text says this is an example. That is our input text. Says this is an example. What we're going to do is to tokenize it, to change it into tokenized text. And like we said, tokenized text is splitting your text into words or subwords. For us to do this simply, we're just going to split it words into words and special characters. So this is an example with a full stop. So the tokenized text will now be this. It is one token, is another token, n another token, example. That's another token. And then the special character, the period, is another token. Keen-eyed, keen-eyed, um, keen-eyed viewers of this course would have seen that I skipped spaces. That was deliberate, just because this is just an example. Sometimes you can skip spaces depending on your use case. You can remove spaces. It saves on memory usage. But in other cases, you do not want to skip texts when you are tokenizing. For example, if you're tokenizing Python code, Python is very, very sensitive to tabs and spaces. So you do not want to do that. But in other cases, you probably wouldn't want the text. So when you want exact text as it is, you keep the spaces like in Python coding. But for your example, we just keep them. So now these are tokenized, right? When they are tokenized, what we're going to do is we are going to go into a dictionary or a vocabulary. We will have a vocabulary or a dictionary that is all the words that we want. And we are going to look for what token ID is this with a capital letter like this. So this capital letter, this, what is the what is the token ID? And we extract the token ID from that vocabulary. For example, it could be 40,134. That is the token ID. And is the token ID could be 2052. 2052, that is the token ID. And the token ID here could be 133. And then 389 is the token ID, for example, and the period is its own token ID, maybe 12. And these, we are going to see how to we actually get them. What we get them just by referencing in a vocabulary. We could have a vocabulary on the side. That is all the words, just word and its ID, word and its ID, word and its ID. And then we just do a lookup. What is the token ID for this? And then we just get all their token IDs. And after that, what we'll do late then is then to embed these. Embed these. Remember, we have our embedding model that would turn these words or these numbers into, if it's 768 dimensions. So this one here, I'm just representing with 3 dimensions. So this 40,000 is now embedded into these 3 dimensions. So each one of those tokens is embedded into three dimensions, or is now being represented by 3D vectors, continuous continuous vectors like that. And that's what we then, these embeddings, those are the ones that we then feed into our GPT like decoder only transformer. That's what we then feed into our decoder only transformer. And after that, we are going to do some post-processing steps. We'll see these steps as we get deeper into the course and the codes themselves. We'll put some post-processing steps, and then after that, we'll have our output text. The reason for this step is things around what are we going to do to convert, because what comes out of this transformer, it's also numbers, because this is a neural network, right? This is a neural network. So if it's a neural network, it's going to do its mathematical calculations inside there, and it's going to split some numbers here. When it splits some numbers, we need to convert back those numbers into text so that we can output text here. But we're going to see exactly how that happens. So we have now tokenized this. So we're going to tokenize the 400, that's 200, 2000, not 2000, 20,000. Just switching back to my code now. So this 20,479 needs to be tokenized. You saw our example here in our very, very simple, we did say it was a very simple split. We're splitting on the word. Here we just we are using just regex. Simple regex, it splits it like this, but keeps the spaces. Maybe we want to split on white spaces. We can do that. We split on the white spaces, but there are some things that we want to clean. So you can follow the codes where the link is for the codes, and you can follow how we are just going bit by bit. The reason it's being done this way is to show how some of the tokenizations, even though it's naive, it's a simple tokenization, we can build it on top of it. We'll be like, oh, should we keep spaces? Should we keep punctuation? So those are the experiments that are being done here. But essentially, at the end, this tokenization scheme is now split that hello, then comma, world dot is this dash dash a test question mark. So these are actually our split tokens or our split words. And then after that, someone would then just look at the vocabulary. We're going to discuss it later, looking at the vocabulary. Right now, we're just tokenizing our words. So in our text coming from the verdict, let's use this same tokenization scheme. And we look at the first 30 words or first 30 tokens in process. It will be I had always thought these are the tokens that we have now. And in our, although there were 20,000 something characters, the number of tokens that we have now in the whole processed text, when we've tokenized it, it's 4,690 tokens. In the next video, we're going to move now to how do we convert these tokens into token IDs? And we're going to talk about vocabularies. So stay tuned for that video.